Greetings everyone, I hope you can hear me well. My name is Guilherme, I am a PhD candidate in the University of Campinas, Brazil, and today I'll be presenting the TintiNet.jl package, a language model for estimation of protein structural properties that I wrote during my PhD. At the time, my field of work was de novo protein structure prediction, which is a global effort to produce structural information from processing protein sequences. This field of work gained a lot of notoriety when DeepMind introduced AlphaFold 2 a couple years ago, and they achieved a surprising level of predictive power, and since then, fueled by that success, processing the very language nature itself utilizes to write protein sequences has become the main paradigm of our field. Of course, the cutting-edge end-to-end natural language processing models have tens or hundreds of millions of parameters and require some serious computing power to be implemented. As a plus, most modern methods build upon those giants and increase the resource requirements even further. We looked at the situation and thought, well, instead of going bigger and better, can we go smaller, faster, and deliver a competitive level of accuracy? We then chose a smaller problem to build our proof of concept network, which was unidimensional property prediction in terms of per residue secondary structure, torsion angles, and solvent accessibility, and set to design our language model. And in order to create it, we set some design principles for our work. First, we committed to deep neural networks with scalable parallel operations, and as a branching of that principle, specifically concerning sequence-to-sequence processing, we avoided recurrent neural networks by design. We wanted our model to be democratic in the sense that it was 100% open source, 100% open data, and could run on consumer-grade computers, and of course, as Julia language enthusiasts, we wanted to make it with Julia using the beautiful ever-growing ecosystem for biological problems and deep learning. We ended up building a pair of classifier plus regressor networks loosely following the DITER architecture, which combines embeddings, convolutions, and transformers on an encoder-decoder network, which generates same length outputs for each input sequence. We used Flux.jl framework to build it, and we made use of the custom layer API to build our own version of a modified wider inception v1 module. So a big shout out to everyone who makes Flux.jl and all its ecosystem a reality. And we also used the transformers.jl contributed transformer layers and the stack API. So a huge shout out also to Peter Chentingwen for his work, and I hope I pronounced your name right. You were fundamental to everything we did here. And in terms of data, we trained on the COTH S50 protein domains with tenfold cross-validation. We used DSSP to extract the target properties, and we also used some tools from the BioJulia ecosystem to preprocess our input-output pairs. We adjusted the maximum sequence length and batch size to make everything fit on a Vel A62 laptop with an NVIDIA GTX 1650 GPU. It has 4 gigabytes of GPU memory. And our complete protocol can be reproduced with all the scripts that are included on the GitHub repository. I've left a QR code on the right side of the slide if you want to check it out. And we benchmarked it side by side with other single sequence property estimators. And we compared some relevant figures of merit on the same validation set. For classification, TintiNet.jl ranked first place on the relevant metrics, which are prediction accuracy and 3-state segment overlap score. For regression, TintiNet.jl ranked second out of the 4 models evaluated on the relevant metrics, which were circular mean absolute errors for phi and psi angles, and a regular mean absolute error for the solvent accessibility. We wanted to note that in case of regression, the top ranking model, Spot1D single, is a huge ensemble of networks with almost 100 times more parameters than TintiNet.jl. So we remarked that we got to be competitive with only a small fraction of the total network size. We also looked at correlations between the classification accuracy and some properties of the input sequence. And after some hypothesis tests, we found no significant correlation between classification accuracy and neither one of sequence length, the degree of homology of the protein, or input or target class abundance. And I brought you here on this slide some scatter plots of those attributes and some zero-value Pearson correlations to illustrate that. And finally, we benchmarked execution times for a model, again comparing them with the three other methods with independent, linearly incremental sample sets of the same average length. And as expected, due to a combination of small parameter pool and the application of our design principles, we were happy to notice that TintiNet.jl was the fastest model to generate a prediction per sequence in average. It was also 10 times faster than the model ranked first place in the regression task. So to wrap everything up, I'm glad to report that given this proof of concept task, which was building a portable language-based 1D property estimator with Julia that could deliver competitive predictive performance and execution time, TintiNet.jl ranks between first and second place on the elected key performance indicators. It also exhibits some attributes which are commonly associated with modern and robust language models, such as uncorrelation, sentence attributes, and quality of token classification. TintiNet.jl is available on GitHub. I've left the QR code to you on the right side of the slide again if you're interested in executing it. If you feel interested in our work, please visit our group's GitHub repositories and see what we do with the Julia language. I'll also take this opportunity to thank our financing agencies in Brazil, which are CAPS, CNPq, and FAPESP, as well as the Institute of Chemistry and the Center for Computing in Engineering Science from the University of Campinas. Thank you very much for your attention, and if you happen to have any questions, I'll be happy to address them.